Well, howdy kids. This is going to be a video that covers ionic compounds. We're going to start off by discussing the ozone layer and why it's important. So the ozone layer is a belt of naturally occurring gas, which we call O3. It sits 9.3 to 18.6 miles above Earth. It serves as a shield from the harmful UVB radiation emitted from the sun. Today, there is widespread concern that the ozone layer is deteriorating due to the release of pollution containing the chemicals chlorine and bromine. Such deterioration allows large amounts of UVB rays to reach Earth, which can cause skin cancer and cataracts in humans, as well as harm animals as well. Chlorofluorocarbons, chemicals found mainly in spray aerosols, heavily used by industrialized nations for much of the past 50 years, are the primary culprits in ozone layer breakdown. About 90% of CFCs are currently in the atmosphere or emitted by industrialized countries in the Northern Hemisphere, including the United States and Europe. These countries banned CFCs by 1996, and the amount of chlorine in the atmosphere is falling now. But scientists estimate it will take another 50 years for chlorine levels to return to their natural levels. So we're going to go and move on and talk about ionic compounds. Ionic compounds contain ions, which are atoms or groups of atoms that have a positive or negative charge. Ions are formed when one or more electrons are lost or gained. So in this picture you can see sodium is giving away one of its electrons, and chlorine here is accepting, it's taking on. Because of that, you get a positive charge for sodium and a negative charge for chlorine, and that's how an ionic compound is formed. So we first need to figure out what happens when elements lose or gain electrons. So if sodium loses an electron, what we're going to write is Na+, because it's getting rid of something negative. And when you do that, you become positive. Magnesium loses 2 electrons. So if magnesium loses 2 negative things, he's going to become 2 positive. Chlorine gains 1 electron. He's accepting an electron, which means it's going to be Cl-. Phosphorus, if it gains 3, it would be 3-. So we have 2 types of ions, as seen in the last slide. We have a cation, which is a positively charged ion. Electrons are lost. Metals tend to form cations. The name of the monatomic cation is the same as the element. So if we're naming these, if we're wanting to name these, and I see Mg2+, and it's positive, I'm just going to call it magnesium ion. If I see this one, Ag, this is going to be silver ion. And this would be aluminum ion. We are positive about metal cats. So cats for cation, and metals because most metals form positive charges. Second type of ion we would have would be an anion, which is a negatively charged ion. Electrons have been gained. Nonmetals tend to form anions. So we're going to name the monatomic anion ending with IDE. So example, chlorine becomes chloride. And we don't have to put the word ion. Phosphorus becomes phosphide, and oxygen becomes oxide. We feel negatively about anions. So when we name ionic compounds, we're simply going to name the ions as they appear in the formula. So I see a metal with a nonmetal. So I'm just going to name the 2 ions. This would be sodium, and I don't have to put the word ion there, and then chloride. Next one is a metal with a nonmetal. And this one would be calcium fluoride. Metal with nonmetal. This is an ionic compound. We have magnesium oxide. So we're going to practice naming the following here. This would be sodium bromide, aluminum oxide, lithium fluoride, lithium sulfide, calcium bromide, potassium, and that's an I, so that's iodide. That's a tricky one. Cesium, and I misspelled that there. Cesium nitride, and then strontium oxide. So this is what you'll be practicing in your practice worksheet there. Go ahead and move on. The charge of a monatomic ion, which means one, mono means one, so one ion can be determined by its element's position on the periodic table. So go ahead and pause this here if you need to write in these values. I'm going to go ahead and move on to the next slide though, but this is what we're filling in. Group 1A has a 1 plus charge, 2A has a 2 plus, 3A has a 3 plus, and then we skip to 5A, 3 minus, 6A, 2 minus, 7A, 1 minus. So I want to show you those on the periodic table. Again, pause the video if you need to, but I'm going to go ahead and look over here, and I may need to present to show you this. Yeah, so the first group on the periodic table has a +1 charge, the alkali metals. The second group on the table has a 2 plus charge. The third group, if we skip the 2A, or excuse me, the transition metals here, we're going to go to 3A over here. That's got a charge of 3 plus. And then the carbon group, this is not in your notes, but if you want to write it in, you can. Carbon can be plus or minus 4. And then the nitrogen group has a 3 minus charge. Oxygen group has a 2 minus charge. Halogens have a 1 minus charge. And then the noble gases, they don't have a charge. 0. So we're going to leave those blank. Elements in group 8A, which are the noble gases, do not form ions. Those are the noble gases. And the elements in group 4, the one with plus or minus, like I just mentioned, they rarely form ions as well. So we usually won't see those in ionic compounds. So what causes the charge? The charges indicate how many electrons an atom will gain or lose. If it loses 2, the charge is +2. If it gains 2, the charge is -2. Got to keep in mind that electrons are negative. The goal of an atom is to become stable. An atom will gain, lose, or share electrons in order for that stability to be attained. Stability is determined by something called the octet rule. The octet rule says that most atoms want 8 valence electrons. And to do that, they will lose or gain electrons. So for example, potassium is in group 1. If you look at this picture, in its outermost ring right here, we have 1 valence electron. In the ring just inside, we've got 1, 2, 3, 4, 5, 6, 7, 8. So potassium would like to have 8. It has 9 right now. It's going to get rid of 1. And to do that, it's going to become positively charged. So if we want to go ahead and look at some more ions, oxide forms a 2 minus. Phosphide forms a 3 minus. Fluorine, fluoride, has a 1 minus. And then sodium, magnesium, aluminum is is a 1 plus, 2 plus, 3 plus, and 2 plus. That's according to the groups. Now, I'm going to post this guy for you, and if you'd like to use it, you're certainly welcome to. But if you look over here, you'll see the names of the ions are written out correctly for you. And then over here in the metal groups, you'll see the names of the ions there, which is just the element name. Some of these in here have multiple charges. You'll see that, and you'll see that there's Roman numerals. We're not going to mess with those right now, but just in case you need to name something, those do use Roman numerals.